This is Samsak, and in this video we are looking at using the normal distribution as an approximate to the binomial distribution. So when n is large enough, and that is usually taken to be larger than 30, so anything above 30, and p is close enough to half or 0.5, a normal distribution can be used to approximate the binomial distribution. And if we were to write the binomial distribution as x is binomially distributed in terms of n and p, so that's a number and probability, then we can change this to normal. And in normal we need the mean and we need the standard deviation. And in order to get the mean, we're going to do n times p, so we're just going to do n times by p. And then to get the variance, not the standard deviation, we will need to square root to get the standard deviation. We're going to do n times by p, and that's going to be times by 1 minus p. So here we have a question, and it says that Andy claims that 60% of his first serves are in, and he serves 50 times, and 26 are in. So assuming Andy's claim is correct, use a normal approximation to find the probability that exactly 26 serves are in. So in this question, we're going to start off by showing it what it would be if it was binomial. So if it was binomial, we're going to have the n. Now n is here, that's the 50 times, which are underlined. And then also the probability, which is here, which I've underlined as well, 0.6. That's the probability. So that is our binomial distribution. Now in order to change that into the normal distribution, we're going to have to do this up here. So that means to get that mean, we're going to do 50 times by 0.6, which is equal to 30. Then to get the variance, what we're going to have is we're going to have 50 times by 0.6, and that's going to times by 1 minus 0.6, which is times by 0.4. That's going to give us 12. Now when we are approximating the binomial by the normal, you have to use a continuity correction. So this means that if in this case, which we have, is the probability of x is equal to x, that means that this is going to be roughly equal to the probability of x minus a half, and then that's in between we've got y, and then x plus a half. Now we'll look at continuity corrections throughout this video, so that's just one example here, and we will have other ones where it's not equal to something, but when it is equal to something, that is what we have to do. So therefore, what we are saying now is that we now have the probability, instead of the probability that x is equal to 26, the probability that 25.5 is less than x, and that's less than 26.5. So therefore, now we have that, we can use normal CD to use our lower bounds, our upper bounds, our standard deviation, and our mean in order to find our probability. So our lower bound is going to be 25.5, our upper bound is going to be 26.5. Standard deviation, that's going to be root 12. If you remember that that's the variance there, was 12. So in order to get the standard deviation, you're going to have to root that. And then mean is going to be 30. So therefore, type that into your calculators, press equal, and what we're going to get, the probability is equal, therefore, to 0.0592. So this question here says that a random variable x has binomial distribution with parameters n equals 30 and p equals 0.4. So if we were just to write this, we could say that x is binomially distributed with 30, 0.4. So now it asks, using an approximating normal distribution, find the probability that a randomly chosen variable will lie within one standard deviation of the mean. So the first thing we have to do here is again change it into this normal distribution so that y is normally distributed. 30 times by 0.4, that's going to be 12. And 30 times by 0.4 times by 0.6 is going to be 7.2. Remember, that is the variance. So therefore now we have that, what we are looking for is we're going to use our binomial CD in order to work this out. So we'll have our lower bound, our upper bound, our standard deviation, and then our mean. Now our lower bound is going to be 12 minus one of the standard deviations. Now the standard deviation in this case is going to be root 7.2. Now we've got this because it asks us find a probability that a randomly chosen value will lie within one standard deviation of the mean. So there's going to be the mean minus the standard deviation, and then the upper bound is going to equal the mean 12 plus the standard deviation. So that time it's 12 plus 12, root 7.2. Then the standard deviation, well, that's going to be root 7.2. And then the mean, that's obviously going to be 12. Therefore, put that in, and our probability is going to equal 0.6827. So the next question asks, does your answer to part A suggest that the normal distribution provides a good approximation? Well, yes, it does. Now this is because if we were to look at the bell-shaped curve again, for example, you've got this, this. And if you remember, from one standard deviation, like that, if that was one standard deviation there, one standard deviation there of the mean here, this middle section here, between these standard deviations, is known to be 68%. Now that's just a fact that you have to learn. Again, if it was 3 standard deviations, that's another fact. It would be, that is between 99.8% between all that area, but between the 2 standard deviations, that means that it's going to be 68%. Obviously, in this question, 0.6827 is roughly equal to 0.68. So obviously it does clearly provide a good approximation. So the next question says that a random variable x is normally distributed with mean 26 and standard deviation 6. So an independent random sample of size 6 is taken from the population. Find the probability that more than 3 of the observations are greater than 24. So as we've got this number, what we're going to be doing this time is actually going the opposite way around and going from the normal distribution to the binomial distribution. So we'll start off by writing this in terms of the normal distributions. So we can say that y is normally distributed, and then it's going to be, the mean is 26, and then the standard deviation is 6. So therefore that's it normally distributed. And then what we're going to have to do is we're saying the probability that x is greater than 24. Now we're doing this so that we can find the probability for the binomial distribution. And it says that that's to find the probability that more than 3 of the observations are greater than 24. So that's why we need to find what actually is the probability that it is greater than 24. So again, we'll be using normal CD for this. We'll have our lower bound, this time of 24. Our upper bound can be any high number, and I normally use 1,000. Then standard deviation, that is going to be 6 in this case, and then the mean is going to be 26. Therefore, put that in your calculator, and what we're going to get is the probability is equal to 0.6306. So now we've got that, we can now put it back into a binomial distribution. So the x is binomially distributed this time, and it gives us the number, because it says that the number is going to be size 6, that's our sample. So we have 6 there, and then we just worked out the probability, and that's 0.6306. So therefore we're looking for the probability that x is more than 3, as it asks for here, which, if you remember back to my binomial video, is the same as 1 minus the probability is less than or equal to 3. So therefore, what we're going to finally get is the probability is going to be equal to 0.6075. So the final question we have says that the probability of a biased dice landing on a 6 is 0.38. So the dice is rolled n times, and using a normal approximation, the probability that a dice lands on a 6 more than 65 times is 0.0438 to 4 decimal places. Find the value of n. So we'll start off by writing what it would be in the binomial distribution. So it's binomially distributed. Now n we do not know, that's why we're having to try and find this value, but we do know the probability of 0.38. Now for the normal, it's going to be fairly similar, but what we're going to have is this is distributed. 0.38 times n is the mean, so it's going to be 0.38n. And then the variance is got by doing n times by 0.38 and then times by 0.62. That is equal to 0.2356 n. And remember, that's the variance, not the standard deviation. So the next thing we need to look at is what this probability is going to be. So the probability, it says that x is more than 65 times. And this is where we're going to have to use a continuity correction because what we have is we've gone from the binomial into the normal distribution, so it's using this normal approximation. That's why we have to use a continuity correction. And in order to do it when it's more than or less than, is you look at what it would be if it was equal to. So if this was equal to something, if it was more than or equal to, it'd be more than or equal to 66. That's the same thing. X is more than 65 is the same as x is more than or equal to 66 in this case. So therefore you'll take the middle value of that. However, if it was, say, x is less than 65, then it would be x is less than or equal to 64, so then it would go to 64.5. Take the middle value of that. So therefore you can say that is equal to probability that x is more than, and then it's going to be 65.5. And we know that that is equal to 0.0438. That also means that if we are imagining our normal, our bell-shaped curve over here, what we've got here, if it's more than 65.5, say 65.5 is there, then we've got that tiny area there, which also means that we've got all of this area around here is going to be less than 65.5. So then we can also say that this is equal to the probability that x is less than 65.5 is equal to 0.9562. So now we have that. Now what we need to do is we need to start using the inverse normal. And we're going to take the inverse normal of this. So we're going to take an area, is going to be this area which you just worked out, of 0.9562. And we're going to be finding a z value. Now if you don't know this, this is what we looked at last video, so go and watch that first if you don't understand all about z values. But an area of that, then we're going to have a standard deviation of 1 and then a mean of 0. So now we have that, we're going to find that is equal to 1.7082. Now that is therefore equal, if we found the mean is going to be 65.5, that is the x value, minus the mean. Now this mean is going to be 0.38n, and that's going to be divided by the standard deviation. Now the standard deviation in this case is going to be root 0.2356n. So therefore now what we're going to have is we have this and we have to solve to find out what n is. So we've done most of it, and now we just have to solve to find out what n is. So therefore we'll times everything by this bottom bit, this root 0.2356n. Remember that n is square rooted as well. So therefore what we'll have is 1.708, and that will be times by, and then if we could do 0.48, that's this rooted, square rooted the 0.2356, 0.4854, then n to the half. And then that's going to be equal to 65.5 minus 0.38n. And then we have to rearrange this, and that's going to give us 0.829 n to the half. Then we're going to be adding 0.38 n, then minus 65.5. That will be equal to 0. So to work this out, we're going to be using that quadratic formula, which we haven't seen for a little bit. So minus b plus or minus root b squared minus 4ac over 2a. Therefore, that's going to be equal to minus 0.829, because if you remember that is b, that's going to be our a value there, the 0.38, and that's going to be our b value. And then it's going to be plus or minus the square root, so b squared, that's going to be, again, 0.829 squared, and then it's going to be minus 4ac, so 4 times by 0.38 times by minus 65.5. Extend that and divide everything by 2a, and 2a in this case is going to be 0.38. That then is equal to 12.083, but that's not our final answer, because that is just equal to n to the half. Because if you imagine using the quadratic formula, normally you would have this as something n squared plus the n. The middle value is normally the m, and we just find that. This is just found n to the half because the middle value is n to the half. So therefore n is going to be equal to that squared, which is equal to 146. So there we are, that is the video using this approximation, this normal approximation. Thank you for watching, and see you soon. Bye.